Yeah, I'm going to discuss about one more questions and integrals. Today almost yesterday I given some basics. I will continue with that basics. Then I will start the problems. Almost it takes around 45 to 50 minutes, 1 hour it takes. I will try to complete all integrals in 1 mark. Always remember, in this topic, you have chances to get 2 questions at 1 mark, right? Two 1 mark questions you will get here. But you can see the possibility of this one, even the weightage of this topic. You can see if we are talking about the weightage of the topic also. See that this is the weightage of the topic. If you are able to see, you can see the blueprint. This is the weightage of the topic. Just you can go through the weightage of the topic. This is just weightage of the topic of each topic you can see here. These are reduced syllabus weightage of the topic. Even I can tell you later, you can see integrals also we have 1 plus 2 plus 3 plus 1 plus 1 plus around total 25 marks. Around 25 marks weightage is there. 1 mark, one question they are giving here. Definitely 1 mark question, one question they are asking here. One question. So if you are thorough with the basics of 1 mark questions, automatically you will understand 2 marks questions, 3 marks questions, and 4 marks, 5 marks question, and 6 marks question also. Basics you are going to learn. So we should be strong with basics. If we strong with basics, then easy to solve other parts. So the questions what I am going to explain now, sometime the question they may ask for 2 marks. The possibility is there. Understood that. So these are blueprint. You can also just go through that. These are blueprint, right? So the topics of the blueprint you can see here. So just you can go through the blueprint as per the reduced syllabus. Correct. This is the blueprint. So you can understand, I think. So the blueprint when I'm showing this. Later I will share also. Okay, fine. Now after saying this, so this work is over now. Here I will discuss with the problems now, starting with the topic now. You can see here the first problem. They are asking the word with antiderivative. They are using the word. Sometimes the question they will ask in 1 mark, find the antiderivative of. See the problem here they will ask. Find the antiderivative of. Antiderivative of. We can see example I'm giving here. They will ask find the antiderivative of e power 2x with respect to x. They may use that antiderivative of. When they are using antiderivative, the meaning is it is nothing but derivative of. But you remember, when we know that d by dx of e power kx, we know that e into e power kx, right? When they are talking derivative of e power kx. But you remember, d by integral of e power kx dx, if they are giving this e power kx by derivative of kx, we should divide. Plus c will write. Plus c will write. They're asking antiderivative of this one. I'm giving an idea about this. Derivative of e power kx, k into e power kx, the comparison you should know. So e power kx dx, e power kx by k plus c. Now you can observe this one. When I was discussing about this one, see antiderivative is nothing but integral e power 2x dx. So I can write e power 2x by 2 plus c. What is to the derivative of 2x? The derivative of kx is k. I can write with this e power 2x by 2 plus c. You can compare with this. Remember, at the same time, derivative and integration, both you can compare. If you learn by comparison, easy to learn integration. Easy to learn integration. Just you remember, antiderivative of e power 2x with respect to x. So the problems with related to antiderivative I am going to discuss now. Although combination of e power 2x with the I am going to discuss about that. So the problems only will discuss about that. Find the antiderivative of. Even you can see this one. 1 year they asked here. This one 2019 March they asked integral. They are asking d by dx of e power 5x dx. They are asking integral of d by dx of e power 5x. So you can see integral of the problem next one. Integral of d by dx of e power 5x d by dx of, this is anti-derivative of this, d by e power 5x dx. They are given this one. You can see your answer is derivative will get cancelled. I can write e power 5x plus c, we can write. I can write e power 5x plus c, I can write. This is your answer, integral constant, I can write. D by dx of this e power 5x plus c, I can write. Antiderivative, if they are using the antiderivative word, I can also write with constant of writing. Meaning is that only derivative will get cancelled, or e meaning of e power, but they are given e power 5x dx. But you can see here, be careful here. They are asking, they are given like this. They are asking this one. It will have d by e power 5x. The answer is e power 5x only. Don't write, because this the derivative will get cancelled, e power 5x it will come. If they ask integral of e power 5x, then your answer is e power 5x by 5 plus c. Sir, why I have written like this? You know, derivative of e power 5x, 5 into e power 5x. If you do integration 5 into e power 5x by 5, your answer is e power 5x plus c. Correct? That way you can think about that related to e to the power of combination. Correct? Only with the talking e to the power of combination, you can solve the problem like this. I am talking antiderivative. The word don't confuse. When they are asking antiderivative, find an integral. Here, they give d by dx of these two will get cancelled. Answer will come e power 5x. See, three different problems. This is one problem, second problem, this is third problem. Think about difference of these three. You should familiar with the difference of these three. Then only you will understand the concept of this. You should familiar. If you are familiar with this, it will be easy to learn. Look into the next one. Suppose antiderivative of. See the next problem I am discussing about. So when they are using the word antiderivative, so the problems are related to antiderivative. You can see, find the antiderivative of 3 power x. Antiderivative of 3 power x with respect to x. They are talking 3 power x with respect to x. Find the antiderivative of 3 power x with respect to x. Everyone learn PUC-PART, this one most important topic, integrals. Find the antiderivative of 3 power x with respect to x. When I am talking about this one, you can see here, we know that d by dx of a power x, we know a power x into log a. Just remember that, derivative of a power x log a. Same time, you remember d by dx, integral of a power x dx is a power x by log a plus c. When they are asking antiderivative, the antiderivative of 3 power x with respect to x. For which the derivative of which function is 3 power x. And the regular direct antiderivative, integral 3 power x dx, you can write 3 power x by log 3 plus c. I can write, when they are asking antiderivative, you can write that. It's nothing but integral of 3 power x. The meaning here, antiderivative of means, if we see here, when I have written like this, the derivative of this is this. Derivative of 3 power x by log 3 is 3 power x. Correct, integral 3 power x. Look into this formula. You can write answer directly. Integral of 3 power x is 3 power x by log 3 plus c. When they are using the word antiderivative. Now again, I am going to explain here. Now, find the antiderivative of sine 2x. These are all problems. Find the antiderivative of sine 2x with respect to x. Find the antiderivative of sine 2x with respect to x. Don't waste the time. Directly you can find integral of sine 2x. But we know that you can see integral sine x dx minus cos x plus c. Just remember. Integral sine x dx minus cos x plus c. Integral of sine of ax plus b dx. If they are given this one, just learn the comparison. Here sine x dx minus cos x plus c. Integral sine of ax plus b dx minus cos of ax plus b. By derivative of ax plus b is a plus c. Derivative of ax plus b, a into 1 constant 0 a. I should divide. In derivative, you multiply. In integration, you should divide. Derivative of ax plus b, you should divide with that. You should divide. You will get sin of ax plus b dx. So they are asking integral sin 2x dx. To compare with this, integral of sin minus cos of d by dx of 2x. Actually, this is the meaning of d by dx of. I can write 2x. You will get minus cos 2x. But derivative of 2x is 2. Just like by comparison, easy to understand. You won't forget. You won't forget this. Plus sin of ax plus b dx minus cos of ax plus b by a is derivative of ax plus b. Derivative of 2x is 2 minus cos 2x by 2 plus c. I should write plus c. I should write integral constant. Integral constant, right? Next, find the antiderivative of cos 3x with respect to dx. Next one is cos 3x. They're talking about cos 3x. Cos 3x with respect to 2x. So when they're talking cos 3x, think about the problem now. Related to integral antiderivative of cos 3x. Find the antiderivative of cos 3x with respect to dx. When they're asking antiderivative of cos 3 with respect to dx, d by dx of sin x is cos x, right? d by dx sin x is cos x. Derivative d by dx of cos x is minus sin x. But integral of cos x dx, you will get sin x plus c, because quite opposite. Integral of sin x, derivative of sin x is cos x. So integral of sin cos x dx, sin x plus c. Same time you remember, integral of cos of ax plus b dx, cos of ax plus b dx. So integral cos sin, because derivative of sin is cos. Always remember, integral of cos is positive. The people, the students may always, they may do mistake when they are writing this, they may by mistake, they will remember derivative of cos will be negative. They may write negative by mistake. You should be careful here. Integral of cos is minus sin of ax plus b. By derivative of ax plus b is a plus c integral constant plus c. After plus c will be the integral constant. Plus integral constant. Find the antiderivative of cos 3x with respect to 2x. When they are talking about this, we can say here, I can integral cos 3x dx. So I can write sin of derivative of this. So 3x d by dx of 3x. So this one I will write sin 3x by 3 plus c plus 3 plus c I can write. This is the meaning of that. Just look. Sir, I remember the formula. Can I write answer directly? Yes, you can write the answer directly. You can write the answer directly. There is no issue. Answer you can write directly, you can write the answer. So sin 3x by 3 plus c when the integral cos 3x. You can write it, no issue. You can write that. Next, find the antiderivative of sin 2x. Find the antiderivative of, see the next problem. Find the antiderivative of sin 2x minus 4 into e power 3x with respect to 2x. Antiderivative of. They're using the word. In the first exercise you are doing these problems. There they will think from derivative they will find answer. No issue. Directly you can find antiderivative is nothing but integral I can find. Integral sin 2x. Because already you are perfect in integration. Directly I can do this. Sin 2x minus 4 into e power 3x dx. We can do it directly. Now if I take this one, integral sin 2x minus cos 2x, derivative of 2x is 2. Integral of e power 3, just we discussed about this, e power 3x by derivative of 3x is 3. This is 3x. E power derivative of 3x by 3 plus constant I can write together, I can write. No need to write here c1, here c2, directly end with one constant. One constant will be enough. So that will be the required answer. They are asking find the antiderivative of. I am talking all the possible questions of antiderivative of. Next one. Find the antiderivative of ax plus b whole square with respect to x. Find the antiderivative of ax plus b whole square and the derivative of ax plus b whole square with respect to x and the derivative of ax plus b whole square with respect to dx. See this, when they are asking antiderivative of ax plus b whole square with respect to x, how to do this one? You can remember integral x power n dx. I can write x power n plus 1 by n plus 1 plus c integral ax plus b whole power n dx. Just observe this one. By observation you can learn, you can observe, you can do the comparison. When they are given like this, derivative of x is 1. When I written this one, ax plus b whole power n plus 1 by n plus 1 into derivative of ax plus b is a, I can write plus c. Derivative of ax plus b I should divide. I should divide. Similar like if I think this integral ax plus b whole square dx, then I will get this answer ax plus b whole power 2 plus 1 by 2 plus 1 into derivative of ax plus b is a plus c. Your answer is ax plus b whole cube by 3a plus c. That will be your answer. Just compare with this formula. Right for 2 plus derivative of x plus b is a. Okay, divide. This will be your answer when they are asking antiderivative of that. Next one, I am going to explain the problems, all the methods, all models, what they are asking the problems here. So this also previous year questions, right? See another question again. Find the antiderivative of, because I don't want to leave all the questions. I am going to explain, I am going to cover almost all the questions of 1 mark. Find the antiderivative of x square into, find the antiderivative of x square into 1 minus x, 1 minus 1 by x square. See this problem. Find the antiderivative of x square into 1 minus 1 by x square with respect to x. This is given problem. This is x square. X square into 1 minus 1 by x square. They are asking antiderivative. Then I can write integral x square into 1 minus 1 by x square dx. I can check this. Multiply x square minus this will get cancelled. X square minus 1 dx. You know this x cube by 3 minus x plus c. Integral 1 dx x cube by 3 minus x plus c. Find derivative of this, you should get this. Definitely you will get that x cube by 3 minus x plus c antiderivative. Correct? Almost all the possible antiderivative questions are completed. There are 2 more questions are there, all previous year questions. These questions are all previous year questions, what I am explaining. Previous year questions. So in next, find the antiderivative of. Find the antiderivative of. Find the antiderivative of 3 sin x by cos square x with respect to x. Don't be the class. I am trying to cover all the 1 mark questions. Definitely you should get the question from that. Antiderivative of 3 sin x by cos square x with respect to x. When they are asking this one, you can observe here 3 sin x by cos square x with respect to x. In this problem, always you can see I can write integral 3 sin x by cos square x dx. I can write 3 into sin x by cos x into 1 by cos x dx. Correct? This will become 3 into, you will get tan x into secant x. But you remember, derivative of secant x is secant x tan x. Remember, d by dx of secant x is secant x tan x. So integral of secant x tan x. Integral of secant x tan x is, we know secant x plus c, quite opposite. Integration is the inverse process of differentiation. So you will get tan x secant x. Your answer is 3 secant x plus c. Your answer is 3 secant x plus c. You will get your answer 3 secant x plus c. Next, one more problem. Actually, these are all questions in the previous papers, questions of previous model papers, all I have collected all type of questions now. See the next problem. Find the antiderivative of 1 by x into root of x square minus 1. Find the antiderivative of 1 by x into, you can write, find the antiderivative of 1 by x into root of x square minus 1 dx. You can think about this problem. Just you can solve that problem. Find the antiderivative 1 by x into root of x square minus 1. X into root of x square minus 1. Find the antiderivative of 1 by x into root of x square minus 1. X into root of x square minus 1 with respect to x. Dimension x greater than 1. X greater than 1. X greater than 1. This case is possible either secant inverse x or cosecant inverse x. You remember here, integral 1 by x into root of x square minus 1 dx. Your answer is secant inverse x plus c. Or I can write minus cos, or you have another answer if you want, or minus cosecant inverse x plus c. Anyone, either this or this, both are correct. Either you can write secant inverse x plus c, or you can write minus cosecant inverse x plus c. Any one of the answer you can write in the case of this one, when they're asking antiderivative of this. So the problems related to that, they may ask here, antiderivative of this one. Suppose if they ask, write the integral of 1 by 1 plus x square dx. Write the integral of 1 by 1 plus x square dx. Write the integral of 1 by 1 plus x square dx. This we know that tan inverse x plus c. Tan inverse x plus c. Just you remember the formula. If they give integral 1 by a square plus x square dx, if they give this 1 by a tan inverse of x by a plus c, the antiderivative of 1 by a square plus x square dx, 1 by a times x by a plus c. If you remember this will be easy to write. That will be easy to write. Next, understood. This is the related questions with related to antiderivative. So these are the questions with antiderivative I covered now. So next one, the combination of, you can see, there are possible questions, another possible question I'm going to explain. Now say another series, like with algebraic expressions. So after antiderivative, I'm going to explain with algebraic, after that with the trigonometry. See the combinations. So now, after completing these problems, I am covering all the models. Now you can see here, I can write. Now, find integral 1 minus x into root x dx. Integral 1 minus x into root x dx. The problems related to this I am going to solve now. Integral 1 minus x root x dx. This is the problem. They asked in the previous exams. 1 minus root x dx. See, in this problem, I can consider this one. It's simple. You multiply root x root x, this one, right? X root x dx. If you want directly, you can write here x power 1 by 2, x power 1 by 2 plus 1, 3 by 2 dx. So this stuff, if you want directly, you can write this stuff. Instead of this, you can write this stuff. You remember the formula here, integral x power in dx, x power n plus 1 by n plus 1 plus c, n not equal to minus 1. Only just you remember this. Correct? You remember that formula? I can write this one, x power 1 by 2. 1 by 2 plus 1 by 1 by 2 plus 1 minus x power 3 by 2 plus 1 by 3 by 2 plus 1 plus c enough. No need to write two integral constants. One will be enough. You can write this is 3 by 2. So 2 by 3, x power 3 by 2 minus this is, you'll get 5 by 2 means minus 2 by 5 x power 5 by 2 plus constant. Enough. The simple procedure, just you multiply, use this formula. Wherever x power n, this is n value. Use this formula, you write your answer. 1 minus x into root x dx. Next one, find integral. That is related to problem. Find integral 1 minus x by root x dx. Find integral 1 minus x by root x dx. Next problem, 1 minus x by root x dx. So this is the problem, 1 minus x by root x dx. Look into this problem, 1 minus x by root x dx. When I am talking about this one, 1 minus x by root x dx, you can observe this problem. When I given like this, I can split this 1 by root x minus x by root x. I can split this. You will get 1 by root x dx minus x by root x dx. If you want, you can make it, this is x power minus 1 by 2. If you remember, integral, I know derivative of x is 1. Yesterday I told one formula, integral f dash x by root f of x, 2 root f of x. If you remember, the derivative of x is 1, directly you can write that. If you remember, otherwise, you go ahead this formula, no issue. If you remember this, you write answer 2 root x. Directly you get 2 root x if you remember. If you are not remembered, then you can write this one, x power, this one minus 1 by 2 plus 1 by minus 1 by 2 plus 1 minus x power 1 by 2 plus 1 by 1 by 2 plus 1 plus c. I can write like this, right? Now you can check here, this you will get, which is equal to 1 by 2, you will get 2 root of x power 1 by 2, 2 root x it will come. This is minus 3 by 2. You get 2 by 3, x power 3 by 2 plus c. Now, why I am explaining this also, along with you should practice all different formulas, you should practice. So practice, it is good for you. You can practice different types of formulae. That's the reason I have explained like this. 2 root x minus 2 by x power 3 by 2 plus c. 3 by 2 plus c. Now you can see now. After that, the problem related another one. Find integral x cube. See the next problem. Find integral x cube plus 5x square x cube plus 5x square minus 4 by x square dx. Look into this problem. That the combination of this, you see this one. When you're talking this problem, you observe here. All combination of this one. I'm doing algebraic functions in one place. But how to solve this? Then you split this x cube by x square, 5x square by x square minus 4 by x square dx. You can split this. X square will get x, this x will get cancelled. I can write integral. This is I can write 1 dx. Sorry, x dx. If you want, I can write 5 into 1 dx minus 4 into 1 by x square dx. 1 by x square dx. Or you can write integral of derivative of 1 by x, d by dx of 1 by x minus 1 by x square. Integral 1 by x square dx minus 1 by x plus c. If you remember this, directly you can write your answer. If you remember this, you can write directly your answer. If you have not remembered this formula, because this most frequent we are using this, we are going to use this. If I have not remembered this, then go ahead this formula. Your answer will get the same thing. You make it x power minus 2. You can do it. Whether you can use any one of this, then you will get into x dx, x square by 2. Integral 1 dx is x, the derivative of x is 1. 4 into, either you can use this formula. If you want to use this, it can be written as x power minus 2. It can x power minus 2 use this. Or if you remember this, directly I can write minus 1 by x plus c. If you want one more step, write x square by 2 plus 5x plus 4 by x plus c. That will be enough. That will be enough. Correct. Related to this. Next one. Find integral x cube minus this one. Next one. Find integral x cube minus 1 by x. Find integral x cube minus 1 by x. Integral x cube minus 1 by x. Find integral x cube minus 1 by x. Integral x cube minus 1 by x dx. Integral x cube minus 1 by dx. When they are given this problem, we can observe this one. I can split this x cube by x minus 1 by x dx. I can split this. Get cancelled, right? Integral x square dx minus 1 by x dx, right? But we know that integral x square dx, x power 3 by 3, 2 plus 1 by 2 plus 1, following this formula. Derivative of x is 1. Derivative of this is 1 is minus log mod x plus c. Formula I told you. What is the formula I told you? Integral f dash x by f of x dx log mod f of x. You can remember this. The f dash is f of x dx log mod f of x plus c. If you directly write that, otherwise think derivative of log x is 1 by x. Even sir, by mistake I written log x only. I have not written log mod x. No, nothing happened. Log x also is right only. Why? Because logarithm exists for only positive numbers. Even if you write log x, that will be right. Don't worry about that. Either log mod x or log x both are correct. So this will be your answer. X cube minus 1 by dx. Next, integral x cube minus x square. Integral. See the next problem. Integral x cube minus x square plus x minus 1 by x minus 1 dx. Just go to this problem. Look into this problem. So when you are talking about this problem, you observe this problem. In this problem, I can write this, I can simplify. Take x square common, x minus 1. Take 1 common, x minus 1 by x minus 1. Correct? I am going to simplify. This is a simple problem, only I can simplify. When I have written like this, you can see here, I can take x minus 1 common into x square plus 1 by x minus 1. Get cancelled, right? Direct now, only one step. Integral x square plus 1 dx. So this is x square means, you know, x cube by 3 plus 1 dx is x plus c. That will be your answer. Correct? So all related algebraic equations I have done. Almost all the algebraic relations we have done this. And another algebraic equations. So the problems which are related to algebraic, I have done these problems now. The miscellaneous I will do at the end. The miscellaneous I will do at the end. Now the problems, another one more problem. Find integral root of ax plus b dx. Find integral root of ax plus b dx. Next problem. See, they are given this. Root of ax plus b dx. Find integral root of ax plus b dx. Integral root of ax plus b dx. If you look into this problem, here also, one model we discussed. Integral ax plus b whole square we have discussed. Find the antiderivative of ax plus b whole square. With respect to x, we have discussed about that. Same concept. When it is given like this root x, like in root x form, I can write ax plus b whole power 1 by 2 plus 1 by 1 by 2 plus 1. Into derivative of ax plus we should divide. D by dx of ax plus b, I should divide plus c, right? I should divide derivative of that. Right, now you can check this to become here, I can write ax plus b whole power 3 by 2. Derivative of ax plus b is here, right? We know here a into 1, this is x, a into 1 constant is 0, right? This will be a. You will get 1 by 2 plus 1, you will get 3a by 2. So I can make it this one. 2 by 3a into ax plus b whole power 3 by 2 plus c I should write plus c. You write plus C equal to plus C is equal to plus C. We should write 2 by 3a into. That will be the answer, required answer, right? And I have taken integral of that one. So with this almost I have completed the problems related to algebraic. I have completed. Now the combination of e to the power of combination. The problems what I am going to ask in e power combination, I am going to discuss. After that, the combination of trigonometric functions. We have three types of problems here. The first model we discussed antiderivative. Second model I have discussed about like the problems related to algebra. Third one related e to the power of. Fourth model I will discuss about like trigonometric functions. Fifth model like about integration by parts also we will discuss. Integration by parts we will discuss the final fifth model. These are the always we have total around 5 models, 5 to 6 models are there to ask 1 mark questions. I am explaining that only here. Now coming to the, you can see the combination of exponential function. Look into the problems related to combination of exponential function. I will write. So you can see this problem we can write here. Integral. You can think about this one. Integral e power x minus x power e plus I can write e power e dx. Or you can think x power e or like this e power e also I can think. Now we shall written like this. This like we have one problem is related to this model. We have one problem is there. I can write e power x, x power e. I get x power e also I can write x power e or e power e also I can write. That was I can write model is same thing. Even that way the problem I can consider. The question I can consider in that way also. X power a, x power e. That model I can consider that problem right. So the combination possibility is there to ask that question, that e power combination, right? E power x minus x power e. Generally, in our book that they have given that combination of like, suppose if they give like this, you think, don't confuse, very simple problem. When they give like this, integral of e power x minus, this is constant here. So integral constant like x power e plus 1 by e plus 1 plus e power e is constant. I can write this is e power e dx plus c. Your answer it will become like this. If any confusion, I can tell if I split that also I can tell you that. If we have any confusion, I can split this. I can write like this. You can see integral e power x dx minus x power e dx plus e power e. E power means I can take it outside. No way related to dx, right? 1 dx I can write. After completing, I will add integral constant. Now I will write e power x. This is constant x power e plus 1 by e plus 1 plus e power e integral 1 dx is x plus c we can add. The constant we can add. I can write like this. Just we can add the constant. Integral constant we can add. This is the problem related to e power x. The next problem. I can write integral, one more problem, algebraic forward integral root x plus 1 by root x dx. Integral root x plus 1 by root x dx. Integral root x plus 1 by root x dx. See, this problem was integral root x plus 1 by root x dx. So March 2017 they asked this problem. March 2017 question paper they asked root x plus 1 by root x dx. So root x plus 1 by root x dx. They asked in March 2017 problem this one. See root x plus 1 by root x dx. This is also simple. You can think about root x means I can write x power 1 by 2 plus 1 by 2 plus 1. Root x means 2 root x, right? Just why I discussed about that. Derivative of x is 1. F dash x by root f of x, 2 root f of x. Even if you not remember formula, you can do it the problem using this. This will come this one. Write 2 by 3 x power 3 by 2 plus 2 root x plus c. Sir, how can you write directly this answer? The previous problem I have discussed about this 1 by root x dx. Or otherwise you consider this one x power minus 1 by 2. You can solve the problem. You can solve the problem. That also is there. Sometimes suppose if they ask root x plus 1 by root x dx whole square. If they ask root x plus 1 by root x whole square dx means you can expand root x plus 1 by root x whole square dx. If they are that will be very easy. Expand a plus b whole square. If you expand a plus b whole square, x plus you get 2ab plus 1 by x dx. Correct? I can write x dx 2 into 1 dx 1 by x dx we can write. If they ask this I can write x square by 2 plus 2 into 1 dx is x. It is 1 by x dx log mod x or log x plus c. I can write like this, right? If they ask the problem related to this. So just these are the possible questions in algebraic expressions. These are all algebraic expressions. Now I will explain the all exponential function combinations. We can see after completing this. See the problem now. Integral I can write. Find you can write. Find the integral of 4 e power 3x minus 1 dx. 4 e power 3x minus 1 dx. If they ask this problem, you can see the in this problem. If they ask this problem 4 e power 3x minus 1 dx, just observe this problem. In this problem, I can split 4 into e power 3x dx minus I can do 1 dx. Now we know this integral e power 3x we discussed just now. E power 3x by 3, derivative of 3x is 3. 1 dx is x plus c. You go through the previous questions, then you'll get an idea about this. I've done this. Next problem 4 e power 3x. Another one. Integral 2x square plus e power x dx. 2x square e power x dx. See, in this problem, I can write 2 into integral of x square dx x cube by 3 plus e power x is e power x plus c. You can write 2 into x cube by 3 plus e power x plus e power x plus c. That will be your answer. X cube by 3 plus e cube plus c. 2 into x cube by 3 plus e power x plus c. Next the problem. Find integral ax square plus bx plus c dx. Find integral ax square plus bx plus c dx. Find integral ax square plus bx plus c dx. Don't miss, solve all 1 mark questions. You'll get complete idea about the integration. Now you can see in this problem, I can split this. Here in integral x square dx, b into x dx, b into x dx plus c into 1 dx, c is constant. Integral x square we know that x cube by 3 I can write x cube by 3. b into x means x square by 2 plus c into integral 1 dx is x plus constant you can add d or k, any one letter. Generally use c, but c already it is here. So you can use any other letter, any constant you can use it. This one. Next. And it is almost well completed related to the problems combination of exponential and algebraic combination. Now I will do the problems. You can say another one. The combination of e power x. When I am doing the combination of e power x, which are these problems related to, will get integration by parts actually. Well, I can do at the end also I will do those problems using integration by part combination. Now, see the next problem. Integral, I can write. Find integral 2x minus 3 cos x, 2x minus 3 cos x plus e power x dx. 2x minus 3 cos x plus e power x dx. Just go through this. When we go through this one, you can see when go through this one, I can write 2 into integral x dx, 3 into integral cos x dx, integral e power x dx. Sir, is it required to write like this? Can I write directly? Yes. If you are thorough, write directly your answers, no issue. You can write that. 2 into x square by 2. 3 integral cos x is sin x. Don't confuse. The people they made a mistake. By mistake they were write minus sin x. Should be careful. Of writing you verify. The root of sin x is cos x. Verify like that. That is most important point. I can write plus e power x plus c. If you want to do, you can cancel. You write x square minus 3 sin x plus e power x plus c. You can conclude that. Even if we stop here also no problem. X square minus 3 sin x plus e power x plus c. That will be your answer. Next one. Find integral 2x square. Find integral 2x square. Find integral 2x square minus 3 sin x. 2x square minus 3 sin x plus 5 root x dx. 5 root x dx. Just you can go through this problem. Look into this problem. If we go through this problem, you can observe in this problem. In this problem, the concept is, you can see here, I can write 2 into x square dx, 3 into sin x dx, plus 5 into x power 1 by 2 dx. If you want, you can split. If it is required, you can split. I can write 2 into x cube by 3. 3 into sin x, be careful, minus cos x. Here you should be careful. You should not do the mistake here. Some people they may write cos x here, but you check derivative of minus cos x is sin x. So that you should be careful here. Plus 5 into x power 1 by 2 plus 1 by 2 plus 1 plus c. You will get 2 by 3 x cube plus 3 cos x. You will get this one. 5 into you will get 5, you will get 10 by, this is you will get 2 by 3, 10 by 3, x power 3 by 2 plus c. Okay, be careful when you are doing simplification. That is most important. Most of the people they may do mistake integral sin x, and the simplification they may do mistake. We should be careful in that case. Next, another one. I'm talking about this one. Next problem. Almost like integral sin x plus the combination. I am doing that. Next, integral e to the power of 2x plus 3 dx. Integral e to the power of 2x plus 3 dx. E to the power of 2x plus 3 dx. When I'm talking e power 2x plus 3 dx, you check this problem. Whether ask e power 2x plus 3 dx, I can write e power of this derivative of this, right? D by dx of. See here I should divide derivative of this. So plus c, you get answer e power 2x plus 3. The derivative of 2x plus 3 is 2. Constant, right? That will be your answer. The beginner explained this thing. So this will be easy to write your answer. Derivative of this is 2. E power 2x plus 3 by 2 plus c will be your answer, right? Next, another one. Integral e to the power of 2 log secant x dx. You see that problem. Integral e to the power of 2 log secant x dx. E to the power of 2 log secant x dx. In the previous section, yesterday we discussed about this. So you remember, e to the power of log m base a is equal to m. You remember this property. Then here I want 2. Here log coefficient should be 1. Here if it is 2, this 2 I can hold here. Then I can write this e to the power of log secant square x base a I can write. So this will be according to this formula, integral secant square x dx. So the derivative of which function is secant square? The derivative of tan x is secant square. Your answer is tan x plus c. Your answer is tan x plus c. You get tan x plus c. Answer will be tan x plus c. Integral secant square x dx is tan x plus c. You will get the combination of that. E to the power of combination. All exponential questions you will get. Integral of e to the power of combination, right? All the combinations of those problems, e to the power of e power 2 log secant x, e power 2 log secant x. Check that next problem I am going to explain with the same combination. See another problem here. When I am talking about another one, you can write integral. Now The almost I completed the combination of this. Now another one, integral e power x into x minus 1 by x square dx. Before doing that, I will remind you the formula, then I will solve that problem. I will remind you the formula. What is that formula? Yesterday also I discussed about this. Integral e power x into f of x plus f dash of x dx. Actually integration by parts. When the derivative of this is here, your answer is e power x into f of x plus c. The derivative of this is here. The derivative of this part is here. So the answer is this. E power x, this is e power x, right? E power x into f of x plus c. Now depend upon this the problem. E power x into sin x plus cos x. You can think about this. Derivative of sin x is cos x. Your answer is this into this, right? E power x into sin x plus c. E power x into sin x plus c. Here the same combination we have integral of e power x into secant x into, see this problem, e power x into secant x into 1 plus tan x dx. 1 plus tan x dx. The combination of this you can say exponential function. E power x secant x into, I can write 1 plus tan x dx. Check this one. You can compare with this, the combination of when you solve that problem. Even you can compare with that, the combination of that e to the power of combination. You can solve that problem, right? E power sin x in 1 plus tan x dx. When they are asking this problem, simple. This one I can write e power x into secant x plus secant x tan x dx, right? Derivative of secant x is secant x tan x, right? You answer this into this, so you will get answer is e power x into secant x plus c. E power x secant x plus c. The combination of this. Correct. I am using this concept. Directly they may ask that formula only they may ask. They will give this one. You should write answer for one mark. They may give that one. You can see here another one. Suppose if they give e power x into, they may also give like this. So here, that like the derivative of 1 by x minus 1 by x square. The derivative of 1 by x minus 1 by x. You can see if I write e power x into the problem here, x minus 1 by x square. If they give like this, the question they ask for 1 mark or 2 marks. E power x into x minus 1 by x square dx. I can write this e power x into, I can split this. X minus 1 by x square, I can split this. I can write this x by x square minus 1 by x dx. So I can strike out this. So this is 1 by x, be careful. If I split this, it will come now e power x into 1 by x minus 1 by x square. So derivative of this is this. Derivative of 1 by x is minus 1 by x square. We know that d by dx of 1 by x minus 1 by x square. Use this formula. Then your answer is this into this into this. Your answer is e power x into 1 by x plus c. E power 1 by x plus c. The question they may ask for 1 mark or 2 marks. The combination of that. Then sometimes they will ask like this one. They will ask. See the formula here related to this one integration by what the question here. So the combination of that. Just you can think about the simple problem. This is a simple problem. Suppose if they ask now the problems related to e to the power of combination I explained. Now I am going to explain the combination of trigonometric functions now. I am going to explain combination of trigonometric functions. If I explain the trigonometric functions, it will be completed the 1 more possible questions. Now you can see now. So here one more problem here I can explain here. This one. Combination of these questions will be, they are asking direct easy questions. I think you can write that I have cleared this. Now suppose trigonometric question now, trigonometric functions. Now in trigonometric functions I can write integral sin x plus cos x. A simple question if they ask integral sin x plus cos x dx. The answer integral sin x I can write minus cos x. Be careful. Cos x means sin x plus c. I'm starting with trigonometric functions. The problems related to trigonometric functions. So integral sin x plus cos x. They must only The question paper they may give easy only this time. So they will all integral sin x or all integral cos x or they will ask. Or integral e power x also they will ask. All integral e power x they will ask is e power x plus c. Correct. The questions they will ask that way. So another one. Just you can see that after that another integral sin square x by 2 integral sin square x by 2 minus cos square x by 2 dx. You go through this. Because sin square x by 2 minus cos square x by 2 dx. If they give this problem, you see, all related to trigonometry I am going to explain here. I don't want to leave any questions here. All trigonometric functions. If they give this one, be careful. When they give this concept is simple here. This is nothing but this is actually we know that sin square x by 2 is cos square x by 2 minus sin square x by 2 is equal to cos 2x. Cos 2 into x by 2. This will be cos x. But that will have minus common is there, right? Since there is a minus common. So you can see that since it's a minus common, that you can think about doing another way this one. Since minus is common, you can think minus common, you take minus common. If you take minus common, this will be minus cos x. Again, if you take minus common, cos square x by 2 minus sin square x by 2 dx. Correct? It will come like this. Then this will come minus, this is nothing but cos x dx. Meaning minus into cos x means I can write. Correct? You got like this cos, simple cos x this one. Integral cos x is minus the integral of cos x is sin x plus c. Again, don't do the mistake when you're writing this answer. Integral cos x is sin x minus sin x plus c is your answer. All possible trigonometric terms I am using here. Next one. Here the another possible questions they will ask. Integral sin x by 2 cos x by 2 dx. Integral sin x by 2 cos x by 2 dx. Integral sin x by 2 cos x by 2 dx. Integral sin x by 2 cos x by 2 dx. So in this problem, 2 is missing. Why? Because we know that sin 2 theta, 2 sin theta cos theta, we know this, right? When 2 theta is here, only theta is here. Just you observe this formula. This I can write 1 by 2, 2 sin x by 2, cos x by 2 dx I can write. Correct? Easily I can write that. Now this one 1 by 2, 2 sin x by 2 cos x by 2 sin 2x, 2 into x by 2 dx. Just go through this formula. When theta, theta, 2 theta, 2 to cancel, 1 by 2, integral sin x dx. You'll get 1 by, be careful. Integral sin x is minus cos x plus c. Answer is minus cos x. When you have doubt, any confusion, verify derivative of minus cos x is sin x. Yes, your answer is perfectly right. Like that, you should verify whenever you are. Be careful. Integral cos x sin x, integral sin x minus cos x. So don't confuse with the derivative. Most of the students they will do mistake in this case. Should be careful. Now after this, the sin x by 2 cos x by 2. The another problem now. Integral tan square x dx. Think about integral tan square x dx. When they're asking integral tan square x dx, so here two types of problem. We have integral tan square x dx. What about the integral tan square x dx? Just think about this integral tan square x dx. So I can write the combination of this one, integral tan square x dx. Think about this problem, integral tan square x dx. So probably we don't know the derivative of any function related to tan square x. No way. But you remember here the formula 1 plus tan square x, which is equal to secant square x. Here the people they will do mistake again. When I was correcting the question, when I was correcting the papers, pre-boards and all that, I observed always they will do mistake here. So you can write here tan square x means secant square x minus 1. Here they will write by mistake 1 minus secant square x. 1 plus tan square x equal to secant square x. They will do mistake here. By mistake they will write 1 minus secant square x. You should be careful in this case when they are doing the problem related to the tan square x. So you can check the problem here, right? So problem is tan square x dx. Now you can check this integral tan square x dx. So what's your answer here? Whenever tan square, you write secant square x minus 1 dx. All previous year questions related to this question, twice they asked this type of problem. I'm going to explain all here only now. So when integral secant square x minus 1, integral secant square x dx minus 1 dx. Integral secant square x is tan x. 1 dx is x plus c. Tan x minus x plus c. You will get tan x minus x plus c. This will be your answer. Tan x minus x plus c. Integral tan square x dx. No, no problem. Integral tan square 2x dx. Integral tan square 2x dx. If the integral tan square 2x, the next problem. Integral tan square 2x dx. Think about this problem. If the integral tan square 2x dx, then in this case, you can think concept is same. I can write secant square 2x minus 1 dx. Don't write here 2. Secant square 2x minus 1. Remember that formula. Secant square 2x minus 1. We will get integral secant square 2x dx minus integral 1 dx. Integral secant square means I can write tan 2x by derivative of 2x is 2 minus x plus c. Derivative of 2x is 2, we should divide minus x plus c. Then I can write that. Correct. Tan 2x by 2 minus x plus c. What formula you can remember here? This formula I should remember. Again, integral cosecant 2019 March they asked integral cosecant square x by 2 dx. They asked integral cosecant square x by 2 dx. Integral cosecant square x by 2 dx. March 2019 they asked this integral cosecant square x by 2 dx. Cosecant square x by 2 dx. Just go through this integral cosecant x by 2 dx. When they are asking this problem, here, what the answer? Derivative of cot x is minus cosecant square x. D by dx of cot x minus cosecant square x plus c. Integral cosecant square x dx minus cot x plus c. Just what is the purpose to write? Whenever you are comparing both, you will remember, you won't forget the formulae. That is the reason I have written minus cot x plus c. So your answer is here minus cot x by 2. Derivative of x by 2, 1 by 2 plus c, right? So how you got 1 by derivative of x by 2 is 1 by 2. D by dx of x by 2, 1 by 2. Minus cot x by 2 you will get. So I get your answer minus 2 cot of x by 2 plus c. That will be your answer. 2019 March they asked this problem. Integral cosecant square x by 2. Right. You can see here. They asked this one. Integral cos 3x dx. June 2017 they asked. Integral cos 3x dx. Integral cos 3x dx. June 2017 or June or July, September, like integral cos 3x dx September supplementary exam. Your answer is sin 3x by derivative of 3x is 3 plus c. Sin 3x by 3 plus c. Sin 3x by 3 plus c. If they are this one, sin 3x by 3 plus c. So related all trigonometry questions. Say again. See the March 16 they asked this problem. March 16 they asked this one. Yeah. March 2016. Integral cosecant x into cosecant x plus cot x dx. Integral cosecant x into cosecant x plus cot x dx. Integral cosecant x into, check that, integral cosecant x into cosecant x plus cot x dx. So this problem they asked this one March 2016 they asked this problem. You can see, you can expand this one. I can write this one cosecant and cosecant square x plus cosecant x cot x dx. You can split that into cosecant square x minus cot x. Cosecant x cot x. Derivative of cosecant x minus cosecant x cot x. Derivative of cosecant x Your answer is minus cosecant x plus c. Minus cot x minus cosecant x plus c, right? Minus cot x minus cosecant x plus c. Correct. So all the problems related to trigonometric functions we are doing right. Almost all the problems related to trigonometric functions. Now, the problems related to trigonometric functions, you see this problem, they're asking integral root of 1 plus sine 2x dx. 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 This is the problem they ask. Integral 1 plus sine 2x dx. They can ask 1 minus sine 2x also. 1 plus sine 2x dx. They have asked this one. We have like 1 plus cos 2x, 1 minus cos 2x. This is the possible problem. They ask like this. Root of 1 plus sine 2x dx. See, in this problem, 1 plus sine 2x dx. If this is the problem, you can see I can write this one. I can write 1 plus sine 2x. Actually, if you think this is cos square x plus a sine square x plus, to understand I'm writing out direct loss, I can write this 2 sine x cos x. A square plus b square plus 2ab cos square x plus sine square x plus 2 sine x cos x a plus b whole square. I can write this cos x plus sine x whole square. Then we will get root of cos x plus sine x whole square. Cos x plus sine x dx I can write. Cos x plus sine x dx. Correct. Now you can think on integral cos x sine x. Be careful. Sine x minus cos x plus c. The people they may confuse. They will write minus sine x plus cos x. Should be careful. Answer is sine x minus cos x plus c. Root of 1 plus sine 2x dx. Next, integral root of 1 plus cos 2x dx. 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 See, in this problem, when they are asking root of 1 plus cos 2x dx, now you can observe here. When they are asking this one, I can write this one root of 1 plus cos 2x. I can write 2 cos square x. 2 cos square x dx. Formula this one. 1 plus cos is 2 cos square x. You remember cos 2x. Cos 2x is equal to cos square x minus sine square x. We know here 2 cos square x minus 1 or 1 minus 2 sine square x. Remember, most important one. You should not forget this formula. Yesterday we discussed about this. So 2 1 plus cos 2 1 you transfer 1 plus cos 2x 2 cos square x. So this will become root 2 root of cos square x is cos x. Root 2 integral cos x. They not mention specific any like the value of x, the range of it. They didn't discuss the domain. You can write directly root of cos square x cos x. You can write. Then you can write integral cos x. So your answer is sin x plus c. Root sin x plus c. Now there is root sin x plus c. So these are possible questions. One more question we have here. Integral root of. I will discuss about it. Just another 10 more minutes I am going to complete the session. So you can see the integrals will be completed. The tomorrow session I will do. Tomorrow Saturday session I will complete. I will do vectors. So tomorrow I am going to do vectors 3D combination. I am going to complete vectors tomorrow. Vectors along with 3D also I can complete tomorrow. Tomorrow I can do vectors and 3D, I can do that. So one more question is possible. Again, they will ask you only see of integration. They will ask one more question in vector algebra, 3-dimensional. Together I will complete tomorrow. And linear programming, only the 10 definitions will be there. I will discuss. And probability. So that I will do Monday evening. Because due to Sunday, Monday you are writing physics exam, I think, right? Pre-board. So that's the reason Monday evening I will complete probability and LPP. That I will complete. With that Monday evening I will complete completely the 1 mark questions of all the chapters. For relation functions I can do Tuesday evening. With this it will be completed. Now, root 2 sin x plus c. If the problem is, suppose 1 minus cos 2x. If it is 1 minus cos 2x from this, whenever cos 2x, from this you can see, this is cos 2x equal to cos 2x equal to, right. If we interchange these two, if we interchange these two, we will 2 sin square x. This will become 2 sin square x, right? 2 sin, it will become sin x, right? Then the problem is 1 minus cos 2x. If it is 1 minus cos 2x, root of 2 sin square x, root 2 sin x, integral sin x is your answer is, you will get root 2 into, be careful, it is sin x minus cos x. So your answer should be minus root 2 cos x plus c. These three most powerful formulae. That's the reason my habit is always remember, don't forget me. These three formulae you should remember to use that word, these three formulae. Next, now the last, almost you can see another problem. See this one, they asked here 2019 paper, integral secant square 7 minus 4x dx. Integral secant square, all trigonometric problems I am doing that. Integral secant square 7 minus 4x dx. Integral secant square 7 minus 4x dx. This is a problem related to like this, right? Integral secant square 7 minus 4x dx. I completed this, right? Secant square 7 minus 4x dx. In this one, they asked in supplementary exam. Integral secant square x we know. Integral secant square x dx, we know that tan x. Why? Because derivative of tan x is secant square x, right? Derivative of tan x is secant square x, right? Derivative of tan x is secant square x. We know that. You remember that integral secant square I can write tan of this one, derivative of d by dx of, I can write 7 minus 4x, 7 minus 4x plus c. Correct. Now you will get derivative of 7 minus 4x, tan of 7 minus 4x by, I can write derivative of this one, constant 0, this is 7, right? Minus 4x minus 4 plus c. Tan of 7 minus 4x by minus 4 plus c, that will be your answer, right? Or I can write minus 1 by 4 into tan of 7 minus 4x plus c, we can conclude that. That will be your answer. The next problem. Integral 1 minus sin x by cos square x. The last problem almost. And the two problems are there. Integral 1 minus sin x by cos square x dx. Integral 1 minus sin x by integral 1 minus sin x by cos square x dx. 1 minus sin x by cos square x dx. See in this problem, 1 minus sin x by cos square x dx. If they are asking this problem, I can split this one. Integral 1 by cos square x minus sin x by cos x into cos x, right? I can split that. Cos x into cos x, I can write this. Correct. You can see here dx. So what is 1 by cos square secant square x minus sin by cos 1 by cos secant x sin by cos tan x dx. Correct. Then you can see integral secant square x is tan x. Secant x tan x is secant x plus c. The derivative of secant is secant x tan x. Derivative of tan x is secant square x. So that will be your answer, right? So almost we have completed all type of 1 mark questions. I have completed. Almost there is no. I think I covered. Almost I covered all the problems I covered here. Nothing is pending here. I covered almost all the problems. So here, these are the maximum possible questions I explained. 1 mark. I hope definitely it will solve because my almost I completed around 40 questions. 40 questions I have completed today. Around 40 questions I completed. If we are thorough these questions, then other parts will be easy. Doing part B, part C, part D, part E, it will be easy. So you do this first. You try to remember, recollect all these questions. You try to solve it. Definitely you are able to solve all the problems. So maximum previous year questions, what they asked the board exams, that also I included. I have completed all type of questions of 1 mark. You go through all previous year papers, even reduce the syllabus also. Even if you go through the previous papers, definitely you can check that whether I covered all the questions or not. So now the next session, what I'm planning, I told you, tomorrow's session will be completely, I will do vectors and 3D together. I will complete vector algebra and 3D also. So just vector algebra and 3D also will complete that. So vectors and 3D, tomorrow I'm going to complete that. Just you can see that the important topic tomorrow I'm going to do that vectors and 3D. So in vectors also you remember when I'm talking about 1 mark questions, the next other topics will be vectors, three-dimensional geometry, linear programming, probability, only probability. Suppose even if we're talking about vectors, so again I should discuss about vectors, the basic things, the basic properties. I will discuss in vectors, and I should discuss here dot product, cross product. I will discuss. So here the topic, only very few points I deleted from this, except that other part I am going to discuss about that. No doubt in that. So tomorrow my concentration will be vectors and 3D. I will try to complete both the topics together. I will do that vectors and 3D. And Monday evening I will try to complete probability and linear programming. Linear programming takes only 10 minutes. Linear programming in 10 minutes. Probability takes only half an hour. Like maximum 1 hour I can take it on Monday class. I can complete all 1 mark questions. I hope I am doing my level best all 1 mark questions. Definitely, you can expect 10 marks, 10 out of 10 in 1 mark questions. If you follow all like these 1 mark questions, almost I have done this is third video. Fourth tomorrow, Monday, fifth. We'll complete almost all the 1 mark questions. After that, I will plan for part B. I will plan for all the topics. Even I should do. I think we have one more possibility. I should do that Tuesday evening or Tuesday morning. Tuesday morning I will plan it instead of evening. Tuesday morning I will plan doing the topic. What the topic I should do? Relations and functions. Because relation functions, it takes 1.5 hours. Clearly, it takes for relations and functions. With that, I will complete. You'll be thorough with the complete subject. So thank you. See you tomorrow at 5 o'clock. If you want to change the time, please let me know. Very few people are attending. Then I can change the time. See you then. Bye bye. Tomorrow we'll discuss about the vectors and 3D. Fine. Let me know who are in the class, the chat box. Pranesh, Srijit,